All right. Hello, everyone, and thanks for joining us here at Programmers Week 2021. Hopefully, you have all been enjoying the content throughout the week from industry leaders of the like of Rocky Laka, Sean Walker, Andreas Angelani, and others here at Cognizant Softvision and from around the globe. For those of you that may not know me, I'm Allen Conway, and I am the Web Client Practice Lead at Cognizant Softvision, where I contribute to thought leadership and building out the web community, along with building custom software applications as a consultant, and have been here for 7 years. I'm really excited to talk about building a PWA using Angular and encourage everyone to share your questions in the chat module so I can answer them accordingly. Without further anticipation, let's get started. Here's some of my contact information for follow-up if needed, as well as the GitHub address for the repo of the samples used in today's session. So my blog, Twitter, email, and that GitHub address. So in this session, we're going to be talking about the following items. We want to talk exactly what is a progressive web app. We want to evaluate it as an implementation versus the other options that we have. The anatomy and setup of a PWA with either an existing app or a net new application. We'll talk about Angular, leveraging the Ionic framework and creating your progressive web app, along with the backbone of PWAs, which are service workers. And also, we'll be taking a look at Lighthouse, which is a tool that'll help us gauge if we've hit the criteria for being a progressive web app. So let's talk about exactly what are progressive web applications and what do we need to do to get started with them. Well, first of all, we'll be using the modern web stack with modern web technology. So as a web developer, as a web client developer, we can use all of our familiar JavaScript libraries and frameworks along with HTML, CSS to build our PWA. And really, this is the crux of it. So during today's session, this is for people who have a development background or a team background in web development skills and need that mobile or native presence, but may not want to do a per platform implementation and don't have that skill set. So it's for folks with a web background that need that native life experience with offline capabilities, installable, and many of the other topics that we'll be talking about today. Now, behind a progressive web app is a design philosophy called progressive enhancement. This is a philosophy that provides a baseline of essential content and functionality to as many users as possible, while delivering the best possible experience to the users of the most modern browsers that can run all of the required code. As we move along and browsers enhance and mature, we will continue to enhance our application to leverage those new features. Also, you should follow the progressive enhancement rule to use technologies to enhance the appearance and utility of your app when they're available, but degrade nicely to those who don't have those features available. Again, we want that native-like mobile-centric experience. Typically the core user interaction is with that mobile experience. PWAs will run in a standalone app window separate from the browser on the mobile device, yet leveraging browser and web capabilities. The application itself manifests as in a Chromeless view without the full browser Chrome. PWAs are installable. This is what gives that seamless gap between a traditional web app, one of the features, and a native application, in that we are able to install our PWA on our device, thus offering the same user experience and advantages as native apps. The application is added to the user's home screen and easily accessible as any natively installed app. We also have reliable and offline capable content. Right? This is very different than a web app that if we lose our connectivity is just down, and we'll take a look at that here shortly. But this is one of the biggest differences between a PWA and a traditional web app is the ability to leverage service workers to leverage caching for access for content that we have previously accessed. So taking a look at the PWA stack, which again this is not a comprehensive, but we're using our familiar knowledge and tools as a web client developer. That's HTML, CSS, JavaScript, TypeScript. We can use any or all of our frameworks and libraries, but we're not restricted to these. You can use Angular, React, Vue, plain JavaScript. Now, one of the things that's going to bridge the gap between true native access and what we're able to do on the web are the web APIs that are available that give us native-like access that's needed through the browser's security model. And that's another important piece to mention here as well. Since a PWA is using the browser's engine, it's using the browser's security model, so the permissions, ability, and privacy is the same as a traditional web app. I'm going to go ahead and look at our application here just briefly. That is the backdrop of this demo. And it is a weather app that is built with Angular and Ionic. And we'll start breaking it down here in a little bit, but I just wanted to show, in this emulator here, what we're looking at. So we have a weather app that relies on the Open Weather API. And we have a zip code search, so we can change our zip code and we can get the current weather. We can get the hourly weather information. It'll make another call out, and we can get the 7-day with icons and current condition, highs and lows and precipitation. And we can change this zip code if needed. And we will get the updated information for the city. We can see a new city. And so this is a decent use case for something that might be a progressive web app, but just a simple backdrop to show how we can demonstrate these features. Let's take a look and talk a little bit about why we would do a progressive web app versus something else, maybe a traditional web app, maybe a native app, a hybrid web app, or something else. So with PWA web development, it's not a hybrid web framework like React, or Capacitor or some other. And it's also not a native app using the SDK, whether Java, Objective-C, Swift. So this graphic over here on this slide really shows that you're getting the best of both worlds. With a native app, you're typically looking at the ultimate in capabilities. With web apps, we have the freedom of deployment and reach because we're leveraging the browser, so we're not tied to any particular operating system. So we're getting the best of both worlds with a PWA. We are not targeting a specific platform like we would with a native application. So we're getting the best of both worlds with a single set of skills, that being our web client skills, leveraging a web app. Maybe one of the biggest drives for creating a PWA is the need for mobile or an offline presence. For example, you could have a use case where, say in the enterprise, you have a bunch of workers that are out in the field. They need to log reports, read data in a remote setting that might occasionally be offline. And you're a team of web developers and not native developers, so you're not looking to make a native application. And also, it's a little beyond the scope of today, but if you think about some of the hybrid web frameworks as well, they do masquerade themselves as having front-end type leveraging skills of the web client and JavaScript when you look at, say, React Native and such. But at the end of the day, you still have to get into native skill sets and deployments and builds that happen on a per platform. And so you do cross that line of having to get outside of the box of just being a traditional web developer. So what are some of the characteristics of what a PWA entails? Well, first of all, fast and reliable. It needs to load quickly, just like a native app. Remember, we're trying to blur that line so that there's not this huge difference to know that this is a web app, versus a true native app. So we'll leverage caching to assist with this. And that's, again, the service worker, which we'll dig into. If the app goes offline, it's still functional. Offline capable allows the user to see any previously navigated to areas that we've leveraged caching. And also there's a caching configuration where we can prefetch and decide and kind of massage how we want our app to behave, which assets we want to get ahead of time while we have connectivity versus lazy. We'll take a look at all that when we get into the service worker configuration. It needs to be installable on the native device and open via an icon on the home screen. It will be displayed in that native container that has the look and feel of a mobile app. Again, service workers being at the heart, they act as a proxy to manage communications between the PWA and the web server. And so it's the brains behind the scenes that will act as the intermediary, deciding which content is going to be returned to the PWA based on the configuration that you've set up. We also need to be optimized for a mobile experience with theming and icons, a splash screen. We also need to have HTTP redirects. It just needs to be blur the lines between a native app and the PWA being a web app. Now, like anything with any decision, we have our pros and our cons with selecting a progressive web app. So let's first focus on what are the advantages? What are the pros? Well, first of all, we don't need an app store. It's not necessarily a requirement anymore because it is installable directly from the browser, maybe from your existing company's page, through some other marketing materials. You can directly install it from a link. You don't need to go through the App Store. Some of the disadvantages of the App Store, if you think of like Apple's strict policy and the rejections that occur over there, we don't have to deal with that red tape. We can use a linkable URL to direct our users to install the application. People likely are, depending on if you're an internal or external product or what your goal might be, if it's external, people are already searching for your products and services through search engines, not in the App Store. There's also been some research and study on App Store and App Store fatigue, that most people get kind of a core set of mobile applications installed, and they're not often venturing out looking for new apps to readily install. So if it's outside the big apps and the core apps that people install, it's often that it could be lost in the App Store itself. Easy to update and deployment. Just like the web, we have that same capability to deploy very easily because we're leveraging the browser, so we can use our same deployment process. We are using a single code base. We're not having one for iOS and one for Android. We're leveraging our web client skills. And again, that's kind of the audience here. We need that native experience. Not only native experience, we can still use Big Web or the traditional browser with a PWA because it's responsive in nature by default. And so we have that ability as well, but we have a single code base. We can use an existing single page or JavaScript application. You'll see that the process to become a PWA is additive. So you can begin either with a new project or we can add in, and we'll see that in our Angular application today. We need to be offline capable. Again, we've talked a little bit about this so that we have that seamless experience, so we don't just get the dead internet, no internet screen. And leverage our existing skill set. We just have to learn a little bit about service workers and how a PWA works. And in the case of the decision to use Ionic, which is an excellent decision, and we'll talk about why that's a great decision, because that helps us bridge the gap between the per platform culture and customization when you're looking at a difference of a PWA installed on Android versus iOS. Of course, there are always cons, some browser restrictions. So when you talk about Safari, there's some limited support and has been for the web app manifest, background sync, web push notifications. Also on iOS in general, the Chrome and Edge are kind of like not first-class citizens like Safari is. So the service worker is only working on Safari. There is a 50 megabyte service worker cache limit, although you can use like something like IndexedDB. There's another nuance where unused web apps that have not been added to the home screen will have their cache purged after 7 days. That could be, if you had a field operator that's working offline for an extended period of time, that would be, and maybe didn't turn it on or get into the application, that could be problematic. Native access, true deep native access beyond what the web APIs will offer us. Since the PWA runs under the browser's security and execution model, you won't be able to, you're only leveraging the web APIs that are available. So if you need something like pure native access with Face ID or ARKit for augmented reality, some of the other native access that's not available through these APIs, you're going to have a problem with the PWA. And I will say it's important on so kind of bending the ear of the architects and decision makers right now. You need to see what the requirements are. It's impossible to see how the app will scale, but to kind of feel out from your product owner what exactly this could entail now and what future vision happens. Because if there is something truly native that is not going to be accessible via these web APIs, that could be a deal breaker for a PWA. There's actually great support for native access through those APIs. But if there's one that's a showstopper, you'll need to, you would want to do that ahead of time, because if you make an app a PWA, invest 6 months, a year, 18 months, and then in V2 or 3, find out there's something you can't get, it's a lot of work to have to basically change the stack to either something like React Native or Capacitor or some other avenue that has, you know, a native wrapper and has access to those true native functionality. So something to be aware about. No store presence. I have an asterisk next to that because you actually can through like the Google Play Store and the Microsoft Store, and you can build a package and have it deployed out there. Now, out of the box, you're not going to have that, but so you don't always have that presence, but if you need it for certain situations, you can configure that. And a service worker complexity. You know, you're not getting anything for free. It's relatively easy, as I'll demonstrate today, but there is some configuration. Thankfully, in the case of Angular, we're able to add the library for the service worker, and we don't have to hand roll a service worker, which is very complex, and we can deal with it through configuration. It's very analogous to in Angular, how we don't normally deal with Webpack directly. We use the Angular JSON file to configure our build behavior. Service worker is much the same, that there's an exposed JSON file, which we'll get into here in a little bit, that allows us to manipulate the behavior of that service worker. What is the anatomy of a PWA? So we talked about the characteristics, but what are the physical the physical pieces that we need? Well, we need a web app. We talked about either an existing one or a new one. And you'll see here when in Angular, we're going to get a lot of this added for us. We don't have to manually add these items, but we will need a web app manifest, which gives the metadata about the PWA, the name, the icons, start URL. We need a service worker and its configuration, the assets and icons, for the install, the icon that goes on the device that will be launched. And we need to serve it up via HTTPS, because the service worker and its communication and power needs to happen over HTTPS. And so whether you're looking at Firebase or Azure, or for local development, HTTP server, because you can run under localhost against the prod build. So that's a convenient way locally to debug, or run, launch, and see the service worker in action when you're working locally. All right, so let's talk about Angular and progressive web apps. I talked to you about the Angular PWA library. So this, again, is additive, and we don't want to be hand rolling. So we can use the Angular CLI and add the Angular PWA package to our application, which will give us the components from the previous slide. So some of that housekeeping, add a link to the manifest in index.html, the theme color, create app icons in the source assets directory to get you off the blocks. And since index.html is the first file downloaded, it has a link to that manifest, so it knows that it is a PWA. Creates the service worker, the manifest, and everything that was mentioned right here. All right, so let's look at, the repo that's out there on GitHub has a couple of different branches with different iterations of the application that we're looking at in the demo today. So this first one that I'm going to share with you here, which is the pre-service worker. So this is just an Ionic Angular application. We have not added the PWA package yet. So I want to say Ionic serve, since this is just an Ionic application and we're not dealing with service workers yet. And this will start the application. Now, this iteration, this branch is just the bare bones version of the app demo I just did a few minutes ago. So when it renders here, the only thing that it has is the search by the zip code to display the city. But what we want to show here, once it comes up, is we'll go ahead and put it into that mobile view again and just make sure that we got everything in good shape. All right, so we have the bare bones application. It just had some titles, and again, if I change this zip code here, then I get the new city name. Now, as we would expect, if I come over here and simulate going offline, all right, over here in the tools, and then I refresh, this is what you'd expect from a web app. You get the cool dinosaur here. It tells us that there is no internet. I have a failed experience. This is what we expect from a web app. All right, so we'll bring it online. And if we refresh it once again, we would get our application to come back. Excellent. So let's go back and take a look here at the next iteration of the application, which is called Angular PWA configuration. Now, I'm not going to run this again, but all you would need to do using the CLI is to put in here ng add @Angular PWA. That will bring in everything that you need to start your journey as a PWA. Once we do that and run that command, let's take a look in this next iteration, the Angular PWA configuration, what we have. All right, down here in the root, we have ngsw config. This is the service worker configuration that I told you is the window into the behavior on how our service worker is functioning. We'll get more into this here in a little bit. Next up, we have that web app manifest. This is again a requirement as metadata, the name of the app, the theme color. In this case, it's the default Angular blue, background color, display. A couple of options here, standalone versus full screen. Full screen is more for a gaming experience because it doesn't have the bar at the top. The domain, which this is covering, and the icons that come out of the box that are for the for installation. And so if we came over to assets and went to icons, this comes out of the box from that, adding that Angular PWA. Of course, you can change these to be whatever is needed. All right, next up, let's take a look at index.html. It is laced in there the requirements that we needed by adding a link to that manifest we just looked at, as well as a theme color and the icon for Apple and iOS that's required right here with this value as well. So it's updated our index.html, first file downloaded in our JavaScript application here, and it will begin the process of knowing that this is a PWA. Lastly, in this, we have the app module, and you'll notice there is a new line here that has registered our service worker. And again, only for production environment, because you don't want to have the service worker running during a development experience that would cache resources that would confuse the development of the experience. So we'll look at this in a little bit, but essentially what you do is you create a prod build of your app, and then we launch it via, I installed this globally. This is just an NPM package, HTTP server, and then I can launch it under localhost in the port. This will enable me to see the service worker in action. Let's go ahead and do that. Let's run the application and bring it up in the browser. All right, and I will bring up this once again, and just for good practice here, let's go ahead and refresh this a couple of times. All right, so in this iteration, we notice a couple of things differently happening here. For one, in the network, we notice that the service worker, after it's been installed, is already in action, taking care of some of the assets. This is very interesting. Also, if you go over to application, we now, under the service worker area, it's found that we do have a service worker as a part of our application. The browser has sniffed this out. And so once again, we have the behavior of the application, and I can change the zip code. All right. Now, let's do that same test again. Let's go ahead and take this application offline and refresh the browser. Well, there you have it. Now, I haven't done all of the configuration yet for everything in this iteration, in this branch, but I didn't get the dinosaur with the no internet. It continued to serve up all of the artifacts that I had either told it to bring to me or that it had already encountered via navigation. So we already have this kind of seamless offline capability in our app because the service worker has served up those assets to us. So that's pretty cool. All right. I'm going to close that one out. We'll stop that. One word, if you're messing with any of these branches and testing it out or doing your own work, if you have multiple, like say Visual Studio Code open or whatever, make sure to stop one before you start another if they're running on the same port so you don't get confused on which one is running. All right. Now let's talk about Ionic and PWAs. It's an open source framework for building those cross-platform apps for Android, iOS, for web. It has a tremendous developer-friendly experience. So if you've ever worked with any component library, whether that's Angular Material or Bootstrap or anything else, there's terrific docs out on Ionic that show you the different components that you would use within your application. That could be Angular, React, Vue, standalone, however you want to use it. There is also a very convenient Ionic CLI that's an abstraction above the Angular CLI, so we can run commands and it will proxy those through and do what's needed accordingly with the Angular CLI. You can install this globally with that command there, npm install global Ionic CLI. To start an Ionic app, like create one, you can say Ionic start and it will guide you through a series of steps and questions and it will start your application. We're also going to look at the per platform styling here in just a second as well. So I'm going to jump over to the third iteration of this here, which is the PWA weather app completed. Now, I'm not going to run all the steps here. I just want to show you some of what occurs if I hit Ionic start. So the first thing up, you'll notice some options down here. It'll show me, is which framework do you want to pick? And you can just toggle up and down, Angular, React, or Vue. So I want an Ionic Angular application. What's the project name? So we can have, whatever the name of the project is. A starter template. You can start with blank, or there's some convenient templates that are like a shell that just get you off the blocks, tabs, side menu. I happen to use tabs in mine. And then you wouldn't normally see this question. This is because this is an existing app. I'm just going to exit out of this. But that's how easy it is. And so once you have it, here is our Ionic application. Now, before I go into some of these components and pieces, I want to demonstrate from you out on the docs for Ionic. Once again, why are we using this? So the question might be, why can't we just use a responsive web app? I mean, can I just do Angular, add the PWA package, have my service worker manifest and be a PWA? Absolutely, you can. There's nothing wrong with that. But as we know in the native world, and if anybody's done any mobile development, there's that per platform environment and experience. Android and iOS don't have their controls and look and feel from a user experience behave identically. So one of the main reasons we leverage something like Ionic is I can use a single control and it will do the behavioral differences on each platform for me. And I don't have to write individual media queries or different CSS or have different versions of the controls and toggle based on environment. Does all that for me. Let's look at this simple example here in this emulator. See the nav here? This is on iOS. And if you look at this, you can see there's like a little bit of an animation. There's an arrow off to the right. So if I click that, it slides over to the left. There's this back that's shown right here with the arrow, and then it slides back to the right. So this is one of the controls. If I go over to Android, let's take a look at the difference. Well, first of all, nav has moved over to the left. On iOS, it was on the right. There is no arrow over here anymore. And when I hit it, it slides up from the bottom. There is now an arrow for a back instead of the word back. And again, I only had to use a single control called Ion Nav. We'll look at another one quickly in the way of the radio, Ion Radio. On iOS, we've got check marks here, a little bit of a basic animation and highlight. But if we head over to Android, we have a more traditional style of radio button and this animation that kind of moves off to the right, what it should be on Android. So this is the reason that we want to leverage something like Ionic. So let's go ahead and take a look at our application and see which pieces, once we add it in Ionic, how does it behave? So starting at our app component, we have an Ion app with a router, all right? This is going to leverage our routing in this application. So right now I have it so that the weather dashboard, that's kind of the shell with the search, is lazily loaded, and that is in the weather dashboard module. So let's go ahead and head over to there. Starting with the module, one of the things that you have seen here is that we have the Ionic module has been imported. That's going to allow us to be able to use the Ionic pieces that we need to in our view. So let's take a look at the view here. All right, so again, I'm using these controls and I'm following the Ionic docs, and they work seamlessly with Angular. It's absolutely wonderful experience. For example, I have Ion tabs here. Those are the tabs at the bottom of the PWA weather app. I have an event when they change that I call in my TypeScript code. I have the search bar at the top, which is where the zip code happens, another event. So on zip code change, what I'm binding to. We've got those tab bar buttons at the bottom with their icons and their label, very intuitive. In that component itself, you're not going to see too much in the way of Ionic specific coding here. This is really just Angular. This is building an Angular application. And so we've got the tabs did change, and we fire off to the service, or actually the observable on the service, to let that know that that's happened. Initially in this, we subscribe to an observable on our weather service to know when that zip code's changed, so that we can essentially call get current weather when that has happened, and we bind that data. We also leverage local storage so that we can save that off in between running it for a seamless user experience to load the last loaded item. Let's take a quick peek at the service here. Again, nothing specific to Ionic here. We have RxJS and observables, behavior subjects for a little bit of state management. Initially, when this loads, we have a default zip code or see if there is one, and then we broadcast that one out. We leverage Open Weather API to make these calls for get current weather, for get hourly weather, and for get future weather. And just a little Angular pattern in practice, like to leverage, fat services and downstream services for front-end presentation layer logic, and have thin components that basically are just binding the data at that point. And so these don't directly return the observable to not try to propagate that bad practice where somebody will get back the raw data and then have to manipulate it in the component. We want to do that here or in subsequent methods and functions or services, and then go ahead and return the finely tuned view model that can just essentially be bound. So if we go back to let's go ahead and go over to the current. So once through the dashboard, the zip code has been changed, and you'll notice here, it's a very thin component for the current weather. It subscribes to that information. And once it gets it, it persists something in local storage, and then the weather data is bound. Let's take a look at our view here. So we have Ion content, which is essentially like an Ion page with full screen set to true, which dictates the behavior so that as I scroll, it goes behind that header. And we have a list header with the title and an icon next to it. We've got an ng container because I don't want to bind data until it comes back, and an Ion grid to kind of lay out that information for the current weather. It's a 12-column layout that's very consistent with other industry frameworks like Bootstrap and others. So it's intuitive. It was easy to learn and use. I have this card header here, and it has the weather location. The card was kind of the main piece of information with that current weather and icon. And then I bind some individual pieces of information with some pipes to format that. Now, at the tabs at the bottom of the page, we did have also the future weather and the hourly weather. So if we look at let's take a look at the future weather. Once again, with the module, we've imported Ionic. And if we look at the component, this one essentially says if the tab is changed and it's subscribed to that, and it knows that this is the tab, we'll go ahead and get the future weather and right here. And then when we subscribe to that, that data comes back and we bind to it. Once again, very thin component, not a lot going on here. This is all Angular, by the way. So nothing specific to Ionic. It can leverage your existing implementation or your new Angular implementation. And again, I want to reiterate, once again, I don't have to use Ionic here. I could just have my pure Angular app and all my existing controls and just have that additive process of putting in the PWA service worker and everything else. But this gives me for free as a developer, as a technical person that has responsible for this implementation, the best of both worlds on all these different environments by leveraging these controls. And so we've got, once again, we've got another Ion content, essentially like a page, a very similar layout. The main difference on, say, the future weather is I've got this NG4 that iterates through and then binds the data repetitively with the icon and the different information. You will find that the hourly component, if we look at that view, is very similar. We're just leveraging a different set of data that also will iterate through the hourly information and give the temp for each hour, the associated icon, and the component is very similar in nature here as well, subscribing once it changes and updating and binding that data. All right, so that's a little bit about why leveraging Ionic for my PWA. All right, let's get into service workers. So the service worker itself is just a JavaScript file running on a separate thread, and it allows enabling caching, background content updating, push notifications, offline functionality, again, to the areas in the app visited or that we've pre-fetched. And so the app can seem even reliably fast on a poor network connection once it's brought that down, those cached assets, because it'll serve it up. Again, the service worker is acting as an intermediary to the actual web server. And so when we're online, it will go to the server. When we're offline, it acts as a cache. Once again, we're going to leverage our configuration. We're going to look at here in just a minute to see how we can change our behavior. I had mentioned it only works in production builds due to we don't want that service worker caching assets or resource during development. That could be confusing. So we also need to use HPS. I've covered that. We can use our local web server and not ng-serve when we're working with the service worker. It's important to kind of have a working knowledge of the service worker lifecycle, because on initial visit to the app, it may not be initially installed on that first launch. It could be on navigation or refresh, understanding some of the events. There is in the dashboard, there is a service that is injected, if you want to look at it, that allows you to tap into when there's a new version available, when it's been updated, when the service worker's installed. When it's basically transparency into the behavior of the service worker, so that you are able to provide a user-friendly experience and set up the behavior of your app however you need to. Also, if you were worried about the service worker ability in the browser, you can look at, can I use .com/service worker, but for most modern browsers, it already is working quite well. And so in the configuration, we're going to take a look at the separate sections. There's URL and cache update policy, the asset groups to decide what's going to be a part of the app. And we'll look at the different options that are on there, as well as the data group section, which is probably the section you would spend the most amount of time deciding which API calls are going to be cached versus freshness and always getting them. And so let's go ahead and straight into that and take a look at this. So if we're back in the PWA weather app completed, let's take a look at the NGSW config. All right, so in here, by default, this will be set up. You'll have a scaffolded file. You don't have to hand roll this after you've added the Angular PWA package. And so it'll point to our index.html. But the first part right here is, what do we need to, the shell of the application? Initially, we absolutely, for the app, we need, index.html, the manifest, and the JavaScript needed to actually run the application itself in any CSS. But now we get into some sections to see, let's take a look like at our assets. So we have these two different modes here, install mode and update mode. So some of the options here, like lazy versus prefetch. Prefetch will go and get those from the web server immediately and have them in cache readily available. Of course, you're going to take the hit, for that because you've made the cost of making that call, versus lazy that won't cache that asset or whatever it is until the user has navigated that part of the app. You have control over figuring out what's important and what needs to be down and readily available in case there's that offline experience, and also for expediency. So in this case, we have on initial install, I don't want to cache any assets until they've gone to it. But on update mode, that means when the service worker notices that there is a new PWA, do you want it to go ahead and prefetch and overwrite those assets in cache? And the answer is yes in that case, because I don't want it to be confusing of a mix in old and new when there is a new version. And in this case, the icons I've prefetched on both the initial install of the service worker and when the service worker notices an update. I need those icons at the bottom for the tabs. I don't ever want those to look broken to navigate between. And next up, our data group. This is the one that normally you would have expand upon this quite greatly. We have a key name for it. And in my case, the URL, and you notice I have this asterisk at the end here. I'm saying everything that goes to Open Weather Map the API, I want you to cache it, but with these settings. So I want to use the strategy of performance. That means I will cache those calls. How many? Up until 100 before it purges it. Also, if they're greater than 1 hour old, I want to go ahead and get a new one as well. And if there's a timeout, more than 10 seconds, we're on a slow connection, I want to go to cache and get it versus getting a new request out from the actual API itself. The other strategy is freshness. There may be a time where you absolutely have to always make that API call. You can go through individual API calls. You can set this up and configure the entire thing to figure out how it's going to behave for your application. And so if we look, again, if we run this application on our HTTPS server and we bring it up and we come over here, we can see, let's go ahead and reload this. Oh, got to bring it back online. Well, that was good. And the service worker is already in action, but I'm just going to go ahead just for good practice and reload this a couple times. You'll see the service worker in action. Let's go ahead and test it out. All right. So for Asheville, we've got an hourly, 7-day, and current. Let's put another zip code in there. And so we've got Beverly Hills, and we've got a couple. We've fetched that information from the API. All right. Let's go ahead and take this offline. Let me navigate to hourly. Bingo. Look right there. And I'm just going to clear that for the next one. I'm going to go over to 7-day. The service worker brought back my data. I don't know that I'm offline. This is fantastic. I mean, a lot of times you think of like an airline application such, you're up in the air, you want to see you've already had the app open that day, and you want to see, what's your next flight and flight information. That's another, any type of information that needs to persist offline, that's what you want to have readily available. In fact, if I go to a zip code that I had already requested as well, there we go. It's all the assets are coming back. I go to hourly, I go to current, and all that was served up by the service worker. Now, what happens if I go to a zip code that I haven't been to yet? All right, so now I did get a failure and the service worker was unable to produce that information. You could handle that more gracefully and show the user you're offline, you'll need to be online to get that info, whatever kind of messages that you needed to do. Again, tapping into that service worker service that is available. And make sure to bring this back online and we can refresh the page and then you get your new city. All right. Just a couple of more things. Validating a PWA. I talked about Lighthouse. It's open source, maintained by Google. It's available in the developer tools where you can install it. What this is a convenient little tool that we can run against our PWA, typically your deployed PWA, to see how it is measuring up against the criteria for a PWA. If you don't want confusion, you can disable browser extensions or run it in incognito to run the test. And so let's take a look here. Let's go ahead and pull up. Let me stop this one. Let's go ahead and stop this one here. Oh, and control. All right. If I go back over here to the application, I have it pushed out to Azure. So here is that same application on Azure. And I want to go ahead and look in the developer tools at Lighthouse. So if you come over here, you'll notice that there's a progressive web app checkbox that you can see right here. So I want to generate the report. You'll notice an emulator comes up. It's running through the process, taking a look at some of these metrics and seeing if you have everything to gauge it. And here we go. We got the output report. We got the green check mark. That's what I want to see. If not, you'd see some red. What details are missing? Again, if you go, in this case, we're talking today about Angular and the PWA library that we installed, the service worker and manifest, the icons, the assets, and everything that we needed. We are deemed a progressive web app. We're running over HTTPS. Everything that was needed was there. So if I come back over here, let's take a look at what a report would look like if we had some issues. So here's an older one that you can see on the left. You know, it's not a progressive web app. It's giving you notifications about what you need, pardon me, to do in order to meet the criteria. Again, it's a design philosophy, so it's not exacting, but there are some core components that you must have available in order to be considered a progressive web app. I talked a few times about those web APIs that are available. You can take a look at the Mozilla docs, you know, whether that's Bluetooth, geolocation, camera beacon, vibration. One cool thing to add to this PWA weather app would be like a button that would use my location that would get the zip code and automatically, you know, update the weather based on that location. And so I could leverage one of those APIs to do that. And again, look at that list. Make sure that you understand if there is something that is not available for your application and your needs. All right, lastly, we talked about installable, the PWA distribution options, and we'll look at installing it directly from the browser. There's an icon that will show up when it is known that it is a PWA. There are some other deployment and distribution options in the enterprise, the App Store, and this convenient PWA builder that you can go to that will help you build a package for, like, say, the Google Play Store if you needed an APK and build that. Again, that's a little bit beyond today, but we're going to look at least in the browser what that looks like. So let's come back to our PWA weather app that's deployed. And if you look right here, you can see if I hover over this icon, install the PWA weather app. All right, so I'm going to go ahead and click that. And it says, would you like to install this? Now, again, that's the icon. That's the default icon. I never did change it. I could change it for weather, but I'm using the default ones from Angular. And I'll say install. If I close the debugging tools, well, there you go. I've got my standalone application running and behaving just like I would expect it. This is now an icon on my desktop that I can launch and have this running without having to go to a URL, without having to pull it up on the web. Another very popular one that a lot of people think about is Twitter. Twitter is another one that's a progressive web. You're able to install it, and you can have that running on your mobile device or Windows or wherever you're working. And then if you want to remove it, you can come in here and say uninstall PWA weather app. I can clear that cache data, and away it goes. And then I can bring it right back up. And here is my application. Excellent. All right. Wanted to show you guys, if you want to screenshot this, of course, this is being recorded, so you can come back to it. Some useful links. That's the repo of the code for today. And remember, there are different branches for the iterations. It's just kind of like a starter to look at and get you off the blocks. Progressive web app documentation, Angular service workers, Ionic, and the CLI, the Lighthouse tool, those web APIs, and of course, Angular and TypeScript. All this information should be a catalyst to get you off the blocks and do what you need to do to get your PWA started, just as I did. I want to thank everyone for attending this session on Programmers Week 2021. I hope everyone has a great day and enjoys the rest of the content and sessions. If there were any questions, I'd be happy to field those now via the Q&A window. Thanks again.
Thanks, Allen. We don't have any questions, but a lot of good reactions. So thank you.
Excellent. Thank you.